The idea of this video is to solve these 12 integrals, which are carefully chosen so you will remind yourself of various methods and tactics which you know for solving integrals. It is that one video to remind you on the curricula on which you are going to be tested tomorrow. The accent here is on the techniques which we are going to use for these integrations. This video is for Calc 2 students, so you have to know integration by parts, use substitution, partial fractions, trig integrals, and identities. And the 12 integrals which we are going to solve today are here on this sheet of paper. So let's start with the first integral. Integral of ln x divided by x cubed dx. We are going to use the DI method to solve this integral. We are going to differentiate ln of x and we are going to integrate the part 1 divided by x cubed, which can also be written as x to the power of negative 3. This is plus, minus, plus, and of course the signs alternate. Differential of ln of x is 1 divided by x, and integral of x to the power negative 3 is 1 divided by minus 2 times x to the power negative 2. And this can be calculated easily, so we are going to stop with the DI method right here. Now this integral becomes ln of x times 1 divided by negative 2 times x to the power of negative 2. We have the negative sign here, so this is minus another integral 1 divided by x times 1 divided by negative 2 times x to the power of minus 2 dx. This is then going to be equal to negative 1 divided by 2x squared ln of x plus 1/2 of the integral dx divided by x cubed. This is then equal to negative 1 divided by 2x squared ln x plus 1/2 times x to the power of minus 2 divided by negative 2 plus a constant c, which is an arbitrary real number. This is then equal to negative 1 divided by 2x squared ln of x minus 1 divided by 4 times x squared plus c. The second integral which we are going to solve is an integral of secant to the 4th power of x dx. Now, if you have an integral of secant to the 3rd power of x dx, you should do that by integration by parts. In this case, when we have secant to the 4th power, it is much easier. We are going to use some trigonometrical identities. Basically, we can write this integral which we have as an integral of secant squared x times secant squared x dx. This is then going to be equal to secant squared x we can write as tan squared x plus 1 times, and just rewrite the secant squared x dx. Now we are going to introduce a substitution that u is equal to a tan of x, and then we get that the differential of u is equal to secant squared of x dx. When we move our integral into the u world, we get an integral from u squared plus 1 du. This is then equal to an integral of u squared du plus an integral of du. This is equal to u cubed divided by 3 plus u plus an arbitrary real number c. This is then going to be equal, when we return it into the x world, to 1/3 of tan cubed of x plus tan of x plus c. Now the third integral which we are going to solve is an integral of 2x plus 3 divided by x squared minus 5x plus 4 dx. Now what we can observe in this integral is that the derivative of the denominator is differential of x squared minus 5x plus 4, which is equal to 2x minus 5 dx. Now what we see is that the u substitution is not going to work in this case because we have 2x plus 3 in our integral. So let's pick a different method to solving this. Let's observe the quadratic equation x squared minus 5x plus 4 equals 0. The idea is to factor the binomial which we have in the denominator, as it is a rational function. So x12 in this case is equal to 5 plus or minus the square root of 25 minus 16 divided by 2, which is equal to 5 plus or minus a square root of 9 divided by 2, which is equal to 5 plus or minus 3 divided by 2. And that is going to give us that x1 is equal to 4 and x2 is equal to 1. Now we can write our equation as x squared minus 5x plus 4 as x minus 1 times x minus 4. A little reminder, if we have an equation ax squared plus bx plus c is equal to 0 and x1 and x2 are the solutions, then ax squared plus bx plus c is a times x minus x1 times x minus x2. In this case, which we have a is equal to 1, so we have 1 times all of this. Just a little reminder so you don't make the stupid mistake. Now the integral of 2x plus 3 divided by x squared minus 5x plus 4 dx becomes an integral of 2x plus 3 divided by x minus 1 x minus 4 dx. And of course 2x plus 3 divided by x minus 1 times x minus 4 can be factored out as a divided by x minus 1 plus b divided by x minus 4. Well, this is then equal to a times x minus 4 plus b times x minus 1 divided by x minus 1 times x minus 4. As the denominators are the same, numerators have to be the same. So 2x plus 3 has to be equal to a times x minus 4 plus b times x minus 1. If we take x as common, we get a plus b, and the remainder is minus 4a minus b. Now we have that a plus b is equal to 2, and that minus 4a minus b has to be equal to 3. If we add these two equations, we get that minus 3a is equal 5, and that means that a is going to be negative 5 divided by 3. b from the first equation can be written as 2 minus a, which is equal to 2 plus 5 divided by 3, which is going to give us 11 divided by 3. If we return all of this, our problem becomes negative 5 divided by 3, integral of dx divided by x minus 1, plus 11 divided by 3, integral of dx divided by x minus 4, which is then equal to negative 5 divided by 3, ln of x minus 1, plus 11 divided by 3, ln of x minus 4, and of course plus constant c. Now the fourth integral which we have on our list is an integral of x squared tan of x cubed dx. Well, this is easy to see. We are going to use substitution as u is equal to x cubed, and then differential of u is going to be 3x squared dx. Of course, we have x squared dx in our integral, so this is going to be 1/3 differential of u. And when we return all of this into our integral, it is going to become 1/3 of an integral of tan u du. And this integral is easy to solve, as it is sin u divided by cosine of u du. And by using the substitution that t is equal to the cosine of u, we get that differential of t is a negative sine u du. This is then equal to negative 1/3 of the integral dt divided by t, and this is negative 1/3 ln absolute value of t plus c. When we return this into a u world, it becomes negative 1/3 of ln of absolute value of cosine u plus c. And when we return all of this into an x world, it becomes negative 1/3 of ln absolute value of cosine of x to the third power plus c. The fifth integral which we are going to solve is an integral of 1 divided by 1 plus x squared and the entire bracket into the power 5 divided by 2 dx. Well, we see that in the denominator we have 1 plus x squared. Since there is only 1 in the numerator and nothing that is dependent of x, our only option in tackling this problem is a trigonometrical substitution. Basically, we are going to use the substitution that x is equal tangents of theta. Then the differential of x becomes secant squared theta d theta. And our integral then becomes, when we transform it into the theta world, 1 divided by 1 plus tan squared of theta to the power 5 divided by 2 times secant squared of theta d theta. This is then equal to an integral of secant squared theta divided by secant squared theta to the power 5 divided by 2 d theta, which is equal to the secant squared theta divided by secant to the fifth power theta d theta. Well, this is equal to an integral of d theta divided by the secant to the third power theta, and what we can use is that secant theta is equal to 1 divided by cosine of theta. This integral then becomes cosine cubed theta d theta, and this is equal to cosine theta times cosine squared theta d theta. This is then equal to integral cosine theta times 1 minus sine squared theta d theta. This is equal to cosine theta d theta minus an integral of cosine theta sine squared theta d theta. This is then equal to integral of cosine theta d theta is sine theta, and at this point we can introduce the substitution that t is equal to sine theta, and then differential of t becomes cosine theta d theta. So the integral becomes minus integral of t squared dt, which is equal to sine theta minus t cubed divided by 3 plus c. And when we return t into a theta world, we get sine theta minus 1/3 sine cubed theta plus c. And when we return to the x world, we get, as x was tan of theta, we have that theta is actually an arcus tan of x. So when we return into the x world, we get sine of arcus tan x minus 1/3 of sine cubed of arcus tan x plus c. Now the next integral which we are going to solve is an integral e to the power square root of x dx. We are going to use the substitution that e is equal to the e to the power square root of x, and then ln of t is equal to ln of e to the power square root of x, which is only a square root of x. Differential of t in this case is e to the power square root of x times 1 divided by 2 square roots of x dx. Now the 2 square roots of x dt is equal to e to the power square root of x dx. This is exactly what we have in our integral, and 2 times square root of x is 2 times ln t dt, that is equal to e square root of x dx. Now our integral becomes 2 times an integral of ln t dt. Now we can use the method of partial integration. We are going to say that u is equal to ln t and that dv is equal to dt. Well, then du is 1 divided by t dt and v is equal to t. So our integral then becomes 2 times t ln t minus an integral t times 1 divided by t dt, which is then equal to 2t ln t minus 2 integrals of dt. That is equal to 2t ln t minus 2t plus c. And when we return into the x world, we get 2e to the power square root of x ln e to the power square root of x minus 2e to the power square root of x plus c, which is equal to 2e to the power square root of x times a square root of x minus 2e to the power square root of x plus c. The seventh integral which we are going to solve is an integral of sin squared of x dx. Now we are going to use some trigonometry to approach this problem. We know that cosine squared x plus sine squared x is equal to 1, and that cosine squared x minus sine squared x is equal to cosine 2x. As we have a sine squared of x, we are going to subtract these two equations. In that manner, we get that 2 sine squared x is equal to 1 minus cosine of 2x. And that means that sine squared of x is equal to 1/2 of 1 minus cosine of 2x. Well, our beginning integral then becomes 1/2 of the integral 1 minus cosine of 2x dx, which is 1/2 of integral dx minus 1/2 of the integral cosine 2x dx. That is equal to x half minus, we are going to introduce the substitution that t is equal to 2x and dt is 2 dx. Then we have 1/2 times 1/2 of the integral of cosine t dt, and that is x half minus 1 divided by 4 sine t plus c. And when we return into the x world, this is x half minus 1/4 sine of 2x plus c. The next integral which we have on our list is an integral of 1 divided by square root of x plus 1 minus a square root of x dx. Well, this integral we are going to solve by fractioning. 1 divided by square root of x plus 1 minus the square root of x times square root of x plus 1 plus a square root of x, and the same is going to be in denominator, as this is entire section equal to 1. This is then going to be equal to an integral of square root of x plus 1 plus square root of x divided by x plus 1 minus x dx. And then we get integral of square root of x plus 1 dx plus integral of square root of x dx. Well, this is equal to integral of square root of t dt if we take the substitution that t is equal to x plus 1, the differential of t is going to be the same as the differential of x. And this is going to be plus the square root of x dx. Of course, this integral can be written as t to the power 1/2 dt. And of course, this is x to the power 1/2 dx. And that is equal to t to the power 1/2 plus 1 divided by 1/2 plus 1 plus x to the power 3/2 divided by 3/2 plus c, which is equal to 2/3 a square root of t to the cubed plus 2/3 a square root of x cubed plus c. And when we return the substitution, we get 2/3 a square root of x plus 1 cubed plus 2/3 square root of x cubed plus c. Well, the next problem we are going to solve is an integral of e to the power x divided by secant x dx. Well, this is equal to an integral e to the power x, and 1 divided by secant x is equal to a cosine of x. So this is just cosine x dx. If we use the di method on this integral, we have e to the power x, and we are going to integrate cosine x. It really doesn't matter in this case which part of the integral you are going to differentiate and which you are going to integrate. So when we differentiate e to the power x, we are always going to get e to the power x. When we integrate cosine of x, we are going to get sine x. And the next one is going to be plus, of course the signs are alternating, e to the power x and negative cosine x. At this point we are going to stop because we have this integral repeating. We are going to multiply these two, and this is going to give us the last integral. So this is equal to e to the power x times sine x, then negative e to the power x times negative cosine x, and plus e to x minus, so minus integral e to the power x cosine x dx. And this is the integral which is repeating. So we have that yacht is equal to e to the power x sine x plus e to the power x cosine x minus yacht, and that is going to give us 2 yachts to be equal to e to the power x sine x plus cosine x. So only yacht is going to be 1/2 e to the power x sine x plus cosine x, and of course that constant c. When we return, we see that integral of e to the power x divided by secant x dx is equal to 1/2 e to the power x sin x plus cosine x plus c. Now this integral is very fun to solve, and it is a little bit controversial. 1 divided by 1 plus cosine x dx. So what is the domain of this integral? 1 plus cosine x has to be different from 0, so this will be defined. We get that cosine x has to be different than a negative 1. Let's see what the trigonometric circle is going to tell us. X, y, and cosine is read from the x-axis. So minus 1 is this point right here. So x has to be different from pi plus 2kp, where k is an integer. I'm going to show you one method how to solve this, and then we are going to solve this integral in a different method. So we are going to use trigonometry. Cosine squared x plus sine squared x is equal to 1, and cosine squared x minus sine squared of x is equal to cosine 2x. When we add these two equations together, because we have cosine of x right here, we have 2 cosine squared of x is equal to 1 plus cosine 2x. We have 1 plus cosine x in our integral, so when we apply that into this equation which we just got, it is going to give us 2 times cosine squared of x half. So our beginning integral becomes an integral of 1 divided by 2 times cosine squared x half dx. We can take the substitution that t is equal to x half, and then differential of t is equal to 1 half differential of x. This integral then becomes dt divided by cosine squared t, and that is equal to tan t plus c. And when we return into the x world, we get tan of x half plus c. Now just a little reminder. Tan x, and we're going to see what a derivative of that is. Tan of x is sine x divided by cosine of x derivative. So this is going to be sine x derivative times cosine x minus sine x times cosine x derivative divided by cosine squared x. This is going to give us derivative of sine x is cosine x squared, because we have this right here, minus sine x. Derivative of cosine of x is negative sine of x divided by cosine squared of x, and that is 1 divided by cosine squared of x. Now the derivative of cotangent function is equal to cosine x divided by sine x, and that is cosine of x derivative times sine x minus cosine x times sine x derivative divided by sine squared x. This is equal to negative sine squared x minus cosine squared x divided by sine squared x. So this is negative sine squared x plus cosine squared x divided by sine squared x, which is negative 1 divided by sine squared of x. So an integral of 1 divided by cosine squared x is tan of x, of course, plus c, and an integral from 1 divided by sine squared of x dx is going to be a cot of x plus c. Now that other method which I was talking about, 1 divided by 1 plus cosine x dx. What we can do? Well, integral of 1 divided by 1 plus cosine of x, now it would be useful to have 1 minus cosine squared of x in the denominator. We are going to make that by multiplying what we already have with 1 minus cosine x divided by 1 minus cosine x dx. In this manner, we get integral of 1 minus cosine x divided by 1 minus cosine squared of x dx. That is going to give us 1 minus cosine of x divided by sine squared of x dx, and that is equal to an integral of dx divided by sine squared of x minus an integral of cosine of x divided by sine squared of x dx. Now you see why I did that little reminder before, because at this point, when solving this integral, many people go to the secant and cosecant, when solving this integral, many people go to cosecants and secants, and it is completely unnecessary. So this is equal to integral of dx divided by sine squared of x. It's right here, dx divided by sine squared of x. It is a cot x. And then minus integral cosine x dx divided by sine squared of x. We are going to solve this integral by introducing a substitution. T is equal to a sine x, and then dt is cosine x dx. So we get the cot x minus integral of dt divided by minus 2 squared. We had integral of 1 divided by minus. Because of this minus right here, I forgot it. So we have minus right here and minus right here. So this is then equal to negative cot x plus integral t to the power negative 2 dt. And this is equal to negative cot x. Now this is going to be minus t to the power minus 2 plus 1 divided by minus 2 plus 1 plus c, which is ultimately going to give us minus cot of x plus 1 divided by t plus c, which is negative cot of x plus 1 divided by sine x plus c. And just a little proof that we didn't miss anything, minus cot x plus 1 divided by sine x is equal to negative cot of x, that is a cosine of x divided by sine of x, plus 1 divided by sine of x. This is equal to 1 minus cosine of x divided by sine of x, and this is equal to 1 minus, we go to the half angle, so we get cosine squared of x half minus sine squared of x half divided by 2 sine of x half cosine of x half. And this is equal to cosine squared of x half plus sine squared of x half minus cosine squared of x half plus sine squared of x half divided by 2 times sine x half cosine x half, which is equal to, these two are going to cancel out, 2 sine squared x half divided by 2 sine x half cosine x half, which is equal to just sine of x half divided by cosine of x half, which is the tan function of x half. So we get the same solution as before, it is just a different method. The next integral on our list is an integral of x minus 4 divided by x to the 4th power minus x dx. Well, we can write this as x minus 4 divided by x to the 4th power minus 1, that is x squared minus 1 times x squared plus 1 dx. And we can rewrite this as x minus 4 divided by x minus 1, x plus 1, x squared plus 1, we can't do anything about that, dx. And when we have a situation like this, x minus 4 divided by x minus 1, x plus 1, x squared plus 1, we are going to factor this out, so it is a divided by x minus 1 plus b divided by x plus 1, and this is x squared. So we have to have a linear function into numerator. So we are going to write cx plus d divided by x squared plus 1. So this is going to become a times x plus 1 x squared plus 1 plus b x minus 1 x squared plus 1 plus cx plus d x minus 1 x plus 1. Of course, divided by the same thing, x minus 1 x plus 1 x squared plus 1. So x minus 4 is equal to a times x cubed plus x squared plus x plus 1 plus b x cubed minus x squared plus x minus 1 plus this is equal to x squared minus 1. So we get cx cubed minus cx plus dx squared minus d. That is going to be equal to x cubed, and in parentheses we have a plus b plus c, basically this part right here. And then we have x squared, that is going to leave us with a minus b and plus d, and plus x, that is going to leave us with a plus b and minus c. I did that wrong. So we have a minus b and minus d. So our equations are a plus b plus c is equal to 0, a minus b plus d is equal to 0, a plus b minus c is equal to 1, and a minus b minus d is negative 4. We are going to take the first equation, a plus b plus c is equal to 0, a plus b, the third equation, minus c is equal to 1, and when we add these two together, we get 2a plus b. These are going to cancel out is 1, and that means that a plus b is equal to 1/2. Now, if we take the second equation, a minus b plus d is 0, and the fourth equation is equal to negative 4, and when we add them up together, we get 2a minus b. These are going to cancel out, is negative 4, and that is going to give us that a minus b is negative 2. So finally, we have that a plus b is 1/2, and a minus b is negative 2. So when we add these equations, we get that 2a is equal to negative 2 plus 1/2, which is negative 3 divided by 2. We get that a is equal to negative 3 divided by 4. And b is equal to 1/2 minus a, which is equal to 1/2 plus 3 divided by 4, which is equal to 4, 2 plus 3, which is 5 divided by 4. So b is equal to 5 divided by 4. And when we return into the previous equations, we had that a plus b plus c was 0. So c is equal to negative a minus b, and that is 3 divided by 4 minus 5 divided by 4, which is equal to negative 2 divided by 4, which is negative 1/2. So c is negative 1/2. And we had an equation a minus b plus d is equal to 0. So d was minus a plus b, and that is 3 divided by 4 plus 5 divided by 4, and that is 8 divided by 4, which is 2. So d is equal to 2. Well, then our integral becomes negative 3 divided by 4 integral of 1 over x minus 1 dx plus 5 divided by 4 integral of dx divided by x plus 1 minus 1/2 of the integral x dx divided by x squared plus 1 and plus 2 integrals dx divided by x squared plus 1. This is equal to negative 3 divided by 4 of ln absolute value of x minus 1 plus 5 divided by 4 ln of absolute value of x plus 1 minus 1 divided by 4. We are going to use the substitution here. Let's say that t is equal to x squared plus 1, and then differential of t is 2x dx. So dt divided by 2 becomes x dx. So this is minus 1 divided by 4 integral of dt divided by t, and plus 2, this is arcus tan of x and plus arbitrary constant c. So this is equal to negative 3 divided by 4 ln absolute value of x minus 1 plus 5 divided by 4 ln absolute value of x plus 1 minus 1 divided by 4 ln absolute value of t, which was x squared plus 1. That is always positive, so there is no need for the absolute value, and plus 2 arcus tan of x plus c. Our final integral is an integral of x squared dx divided by a square root of 1 minus x squared. So what is the domain of this integral? 1 minus x squared has to be larger than 0 because it is under the square root and it is in the denominator, so it can't be equal to 0. We have that 1 is larger than x squared, and that means that x has to be from the interval from minus 1 to 1, and that is an open interval. Well, what we can see now is that the obvious thing to do is to introduce a trigonometrical substitution that x is equal to a sine of theta, and then dx becomes a cosine of theta d theta. This is then equal to an integral of sine squared theta divided by a square root of 1 minus sine squared theta, and we have cosine theta d theta. This is then equal to an integral of sine squared of theta divided by a square root of cosine squared theta times cosine theta d theta. This is equal to an integral of sine squared theta divided by absolute value of cosine theta times cosine theta d theta. And how you can get rid of the absolute value? Well, absolute value of x, where x is any number, is equal to x times a sine of that number. A sine of number x is a function which gives us 1 for x larger than 0, 0 for x is equal 0, and negative 1 for x smaller than 0. So this is going to become, well, integral of sine squared theta divided by a signum function of cosine theta times cosine theta times cosine theta d theta. These two are going to cancel out. A signum of cosine theta, that can go in front of the integral because that is a constant. So we have integral of sine squared theta d theta, which is then equal to signum of cosine theta times, we already had this integral, and it is theta half minus 1 divided by 4 sin of 2 theta plus c. And when we return the substitution, we get signum of cosine of arcus sine of x times arcus sine of x divided by 2 minus 1 divided by 4 sine of 2 times r cos sine of x plus c. So thank you for watching this video. If you have found it to be useful, please like, share and subscribe to my channel. I'm looking forward to seeing you in the next video.